Hey everybody, in this example, which is quite similar to a couple of examples coming up in the playlist after this, but in this example, I'm going to use probably the longest approach to doing something like this, and in the next two videos, I believe, two or three, I'll have similar examples, but I'll use different techniques. So they're all beneficial. You can use more or less any of them in any of the examples. And I'm just trying to show you a good variety of ideas. Okay. So here we are going to simplify this. I have my flashcard set up. I use these 3x5 big index cards. I wrote out my expression that I want to simplify on one side nice and big, and then a little bit smaller on the other side so we can work it out, right? So for this particular example, I'm going to start off by using a reciprocal identity to rewrite secant theta. So what will that give us? We'll have cosine theta times secant theta is 1 over cosine theta minus cosine theta, which is really over 1. Now, we can't do anything with these two expressions inside here because you can't add or subtract things unless they have, correct, a common denominator. Thank you for participating. Now, what I'll do is my least common denominator will be cosine theta. That means I'm going to take my cosine theta over 1, and like you've been doing since you were 9 years old, I think, I don't know, we'll be multiplying the numerator and denominator by cosine theta, because that is the same as multiplying by 1. 1 is a multiplicative identity. We're allowed to multiply by it. Love it. So all that is still happening in my parentheses. So this whole thing moved to this step here, right? So we're just simplifying, right? I know it looks bigger, but sometimes things get messier before they get better, right? That's life. Cosine theta. Now, I'm really dragging out each step so you can really see everything, minus cosine squared theta over cosine theta. Now, normally I probably would skip this particular step, and in the next step instead, I would draw one jumbo fraction bar, since they are, we are dealing with a common denominator now. Let's put it all together and make my numerator over this whole thing right there. Okay, so this went to that line, that went to that line, but now this, go over here. Okay, so we have cosine theta still sitting out in front. Now, what do we remember about 1 minus cosine squared theta? I hope that you're shouting at your video, phone, screen, whatever right now, that it's sine squared theta, of course, obviously, over cosine theta. Now, you don't have to sit there and be like, oh my gosh, well, sine squared over cosine, I can't make that tan because one's squared and one's not. Sure, could you make it like sine times sine and then do sine over cosine and then sine by itself? Yeah, but we don't need to, because what happens to the cosine? We are only multiplying and dividing. No addition or subtraction is involved like it was in the original, right? So we are allowed to reduce, simplify, cross out, right? So cosine theta, bye-bye, that equals 1. And all that's left behind is sine squared theta. So in conclusion, this mess over here is equivalent to sine squared theta. I hope you found this example enlightening, helpful, clear to follow. I hope that even if you did it a different way by yourself, that you got it correct. And I hope that you could recreate an example similar to this one on your own in the future. So if you feel confident that you can do something like this, or you understood, thumbs up. If you hate me and don't understand, put thumbs down. My feelings won't be hurt. I'll just know that you need more of this kind of example from me. All right. So jump to the playlist to look for other examples that you might want to watch, or just click the video that pops up on the screen as the next in the playlist. All right. Enjoy the rest of your day.